The Antarctic ice sheet appears from above to be a tranquil, permanent ice blanket that has occupied Antarctica for decades. Today we will be telling you about NASA's insane new discovery under Antarctica's ice. Watch this video till the end, like and share, and don't forget to subscribe to our channel. At its thickest, the ice sheet can be thousands of meters thick, concealing a lot of meltwater lakes, where the base of it connects to the bedrock of the continent. Few lakes from these fill and drain all the time beneath the surface through a system of canals that finally drain inside the ocean. Scientists have enhanced their maps of these secret lake systems beneath the West Antarctic ice sheet, using the latest and best Earth-observing laser equipment NASA has ever flown in the universe, and uncovered 2 more active subglacial lakes. The new research is important for recognizing new space subglacial lakes, as well as determining how the secret plumbing system affects the rate at which ice falls into the Southern Ocean, including fresh water that could disrupt the ocean's circulation and organisms. Scientists were able to image the subglacial lakes using NASA's icesat. The satellite measures the height of the ice surface, which rises and falls as lakes fill and empty beneath the ice sheet, despite its immense thickness. Meltwater lakes are hidden deep beneath ice sheets of Antarctica. NASA's Ice Cloud and Land Elevation Satellite 2, or icesat, uses a powerful laser altimeter device in space to enable scientists to view beneath the ice. The report, which was published in Geophysical Research Letters on 7th of July 2021, combines height data from the predecessor of icesat, the icesat mission that's original, and the European Space Agency's Cryosat-2 satellite, which monitors polar ice thickness. For decades, the hydrology systems beneath the ice sheet have remained a mystery. That started to modify in 2007 when a glaciologist, Helen Amanda Fricker, at the University of California, San Diego's Scripps Institution of Oceanography, produced a breakthrough that helped in updating subglacial lakes' classical understanding in Antarctica. Fricker discovered for the first time, using data from the initial icesat in 2007, that beneath fast-flowing ice streams of Antarctica, an extensive network of lakes connect, actively filling and draining over time. These lakes were formerly assumed to contain meltwater in a static state, not filling and draining. A big discovery from the icesat mission was the finding of these interconnected lake systems at the ice-bed interface, which are making the water move, with all these effects on oceanography, glaciology, and microbiology, said the assistant teacher of geophysics and lead researcher in the new study. After using icesat, is like putting on your spectacles. The data are so precise that we can actually begin to map out the boundaries of the lake on the surface. Subglacial water exchange in Antarctica, according to the scientists, is caused by a combination of factors, including variations in the pressure given out by the huge weight of the ice on top, friction between the ice sheet's bed and the rocks beneath, and heat rising from the earth below that is insulated by the ice's thickness. This is in sharp contrast to the Greenland ice sheet, where meltwater drains through the cracks and holes in the surface, filling lakes at the ice sheet's bed. Siegfried collaborated with Fricker, who designed the method the icesat mission observes polar ice from orbit, to research the places where subglacial lakes fill and drain more regularly using satellite data. According to Siegfried and Fricker's new research, a group of lakes under the Mercer and Whillans ice streams in West Antarctica, including the Conway and Mercer Lakes, are going through a draining period for the 3rd time from the original icesat mission. He started measuring elevation modifications on the surface of the ice in 2003. This area also contains the 2 newly discovered lakes. The study demonstrated that the contours or limits of the lake could vary gradually as water comes and exits the reservoirs, in addition to giving crucial data. At this stage, we're mapping out any height anomalies, Siegfried added. With icesat, we'll be able to monitor lakes that are overflowing and draining below the ice sheet, helping us in observation. If scientists wish to know more about the subglacial plumbing system and how all of the fresh water may affect the pace of the ice sheet above, or the circulation of the ocean into which it eventually flows, precise measurements of basal meltwater are critical. The Antarctic ice sheet, a vast layer of ice in the shape of a dome, covers most of the continent, spreads gently outward from the continent's central region, similar to extremely thick honey. However, as the ice nears the coast, it slows dramatically, forming ice streams, like rivers that funnel ice up to several meters per day toward the ocean. The style meltwater that lubricates the sheet of ice as it travels over the underlying bedrock determines how quickly or slowly it moves. The ice sheet develops fissures, crevices, and other flaws as it advances. When lakes beneath the ice receive or experience a lack of water, the frozen top above deforms. icesat-2, which uses a laser altimeter device to measure Earth's surface in unprecedented detail, maps these elevation variations with a precision of just some inches. icesat-2 will supply height measurements to scientists to help them develop a worldwide picture of Earth's third dimension, allowing them to track changes in terrain such as glaciers, forests, sea ice, and more. ATLAS, the Advanced Topographic Laser Altimeter System, is the single instrument on icesat-2. It will measure melting ice sheets and investigate how this affects the rise of sea level, research changes in the mass of glaciers and ice sheets, estimate and study thickness of sea ice, and measure the vegetation height in forests and other ecosystems around the world. Long-term satellite missions tracking those complicated dynamics will provide critical insights into the ice sheet's fate. Observations of the way polar ice is changing in response to warming and ocean have contributed significantly to what glaciologists have learned about ice sheets in the last 20 years. Still, secret procedures like the way lake systems take water below the ice will also be essential in the future education of the ice sheet of Antarctica, according to Fricker. These are procedures happening beneath Antarctica that we wouldn't know about if it weren't for satellite data, Fricker said, underlying how her 2007 finding allowed geologists to confirm Antarctica's underground plumbing system transfers water far more quickly than previously assumed. We have been facing trouble making correct predictions about the future of Antarctica, and inventions like icesat-2 are our assistance in observing at the scale of the process. A water system that's intertwined with the whole system of Earth. One of Antarctica's best-kept mysteries is how fresh water from the sheet of ice can affect the Southern Ocean's circulation and marine life. Because the continent's subglacial hydrology is so important in making that water travel, Siegfried also stressed the ice sheet's relationship with the rest of the world. We are not only discussing about the ice sheet, Siegfried explained, we're discussing a system of water that's interconnected with the rest of the planet. Recently, Fricker and one more group of scientists watched the relationship between the Southern Ocean and the freshwater, this time by looking at lakes near the surface of an ice shelf, which is a big part of the ice that floats on the ocean like an extra area of the ice sheet. According to their findings, a big ice-covered lake in East Antarctica rapidly collapsed in 2019 after a crack or fracture formed from the lake surface to the base of the Amory ice shelf. The scientists evaluated the harsh change on the ice shelf's landscape using data from icesat-2. The catastrophe created a dew line or sinkhole around 4 square miles in size, or that thrice of Central Park in New York City. Within 3 days, the break flowed approximately 200 billion gallons of fresh water from the ice shelf surface into the ocean below. Thousands of blue meltwater lakes beautify the brilliant white surface of Antarctica's ice shelves during the summer. However, this unexpected occurrence occurred in the dead of winter, when experts anticipated the water on the ice shelf surface to be totally frozen. icesat-2's laser beams can depict the tremendous change in the topography prior and later the lake was drained, even in the darkness of the northern winter, because it orbits Earth with precisely repeating ground tracks. The wounded ice shelf was originally detected in photos from Landsat 8, a NASA USGS cooperative mission by Roland Warner, a glaciologist with the Australian Antarctic Program collaboration at Tasmania's University. According to Warner, the drainage event was most likely produced by the hydrofracturing system, where the mass of the water of the lake drove a surface fracture clear through the ice shelf to the ocean below. The whole thing bends upwards, centered on the lake due to the reduction of this water's weight on the floor of the floating ice shelf, Warner explained. That would have been tough to figure out simply by looking at satellite imagery. At the time of warmer months, lakes and meltwater streams appear on Antarctica's ice shelves. Because scientists predict that when air temperatures rise, meltwater lakes will become more widespread. The probability of hydrofracturing will rise as well. Thank you for staying throughout. Let us know your review in the comments below. Stay tuned, stay safe.